See, you people should respond immediately when I ask some questions. Is that fine? Hello?
Yes, ma'am.
Okay. So in today's class, we are going to talk about the last topic of that particular chapter, that is called bidirectional protocols. Okay. So see, previously we studied in case of TCP, like there are 4 protocols, right? If you remember the 4 protocols, one we talked about simple protocol, next stop and wait, third go back N protocol, then fourth selective repeat protocol. So these 4 protocol what we have discussed, okay, they are unidirectional protocol. Okay, so what is that unidirectional protocol we are talking? That means only the data or the packets, okay, it can flow only in one direction, right? That means if at all this is the client, okay, and this is the server, a client can send the data, okay, and receiver or send server can send the acknowledgement for the respective data which is received. Okay, now the condition is when the data is sent, okay, it is only bidirectional. That means client only can send the data, receiver should only receive it and acknowledge. Okay, so it was unidirectional. Okay, uh, but in real life what happens is we may not always choose the client or server to be unidirectional, because the normally flowing of the data or the packets will be from both the ends or both the directions, right? That means whenever client is having data, at the same time even server may also has data to send to the client. Okay, so in that way the acknowledgement has to be sent for the data of the client, as well as acknowledgement has to be sent for the data of the server. Okay, now this means basically, ma'am, Gitanjali ma'am, क्या ನಾನು ಕೇಳಿಸ್ತಾ ಇದ್ದೆ ನೀಟಾಗಿ. Yeah, sorry for the inconvenience. Am I audible now? Hello. Okay. See, when the data has to be shared between both the client and the server, we call it as bidirectional protocols. Okay, we'll talk about piggybacking added to it. When we say that it is bidirectional protocol, as I told you, there is a flow of packets in both the direction. Now, what is piggybacking? Piggybacking is in order to reduce the load of the network. Okay, in order to reduce network load. Okay, what happens is instead of sending only acknowledgement at a time, along with the acknowledgement, some part of the data is also attached and sent to the receiver. Okay, similarly here also client will, along with the acknowledgement, he will add some data and send to the server. Okay, so that means what happens is, see, first you know what happens, I have to send the acknowledgement, then again send the data, so it is like 2 times doing the same process. It's a really tedious job, right? So in order to avoid this process or reduce the load of the network, the acknowledgement with along with an acknowledgement, say for example along with acknowledgement number is there, and some amount of data with the sequence number, checksum and the packet, that is data. Okay, it is attached with the acknowledgement and sent in both the directions. That means if the client is having, he will attach. If the server is having, the server will attach it along with the acknowledgement. Some data is added. Okay, so that is called as piggybacking. Okay, any doubt? Here you can see that this picture, this is basically the layout for go back and protocol. Okay, when it is implemented bidirectionally. When it is implemented bidirectionally. So definitely we know that earlier we had only unidirectional protocols, right? Later, to improvise the efficiency of bidirectional protocol, the go back N was implemented bidirectionally. And this picturization, whatever is shown, is the windows for communication from client to server, similarly server to client. And we know that in case of go back N, if at all a sender is having, sender will be having the buffer, okay, and receiver will be dealing with only one packet at a time. So it will not have any buffer. Similarly, if a server is sending, it is acting like a sender, then the buffer will be there only for the sending packets, not for the receiving packets. Okay, so the buffer, and if the client is acting like a receiver, in that situation, he will deal with only the respective particular packet. Okay, so here this is the client send window, where you can see that the window size is fixed to 0 to 2 power m minus 1. Okay, that is S size of the sending window, where some amount of packets which are shown in the blue color are sent to the destination waiting for the acknowledgement, and some are still ready to be sent, and the receiver will receive the particular packet. Okay, and in case if any other packets comes in out of order, that receiver will discard. Similarly, server, whenever he is having some data, and he will do the same process. Okay, with the client, you will receive only one packet and send the acknowledgement. Say for example, if the server is sending x the packet, he will acknowledge with x plus 1, right? What next to receive? Okay, so that packet he will acknowledge to the server back. Similarly here also, if x is the number, sequence number, x plus 1 is the acknowledgement. Okay, see, normal go back in protocol, normal function. Okay, but only thing is you are adding the bidirectionality in this particular protocol in order to improvise the efficiency. Is that clear? Is that clear?
Yes, ma'am.
Okay. Next, we'll talk about the next chapter of this module 4. Okay, that is transport layer protocols. Now let us consider. See, so far in the transport layer, we discussed about many concepts, right, related to the transport layer. Along with that, we started up with the protocol called TCP, right, transmission control protocol. In that also we tried to see some additional concepts like what are the characteristic services, what is its header, and how the basic efficiency of TCP. I mean, so many concepts like about the TCP we try to analyze. Still lot many is there, everything we cannot cover up in this particular duration. But still, I mean, even if whatever is major things I have just covered it. We have one more protocol in the transport layer. Today we are going to talk about it. That is user datagram protocol, which is in short we call it as UDP. Okay, see, this user datagram protocol is basically a connectionless protocol. and it is unreliable protocol. That means whatever the packets you are sending, you're not sure it is reaching the right destination without any error. Okay, so that means it is completely unreliable, may reach, may not reach, something like that. Okay, so it is completely unreliable transport protocol. And whenever communication is happening, okay, it is bothered only about like process to process communication. Okay, so it will not add anything else. Okay, um, any other services. Okay, if at all I'll tell you what about the services and all. So no other services or any other services are not added. Okay, like services of IP. Okay, IP services are not at all added in case of UDP. Okay, that means like you talk about IP host to host communication, right? Okay, so none of the services are being like added by the UDP. He will just concentrate only with respect to the process to process communication. Okay, and we know that UDP is so powerless, correct? No, that means see, it is not doing anything. That means additional parameters, additional features, or even it is not reliable, right? No, so many disadvantages. With all these disadvantages, we come up with some small advantages which makes UDP to be used in some of the applications. Okay, so and that we'll discuss in the coming topic. Now UDP is basically a simple protocol. Okay, UDP is a simple protocol, and it makes use of minimum overhead. Okay, definitely ಏನು ಕೆಲಸ ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ಓವರ್ ಹೆಡ್ ಎಲ್ಲಿರುತ್ತೆ, ಕರೆಕ್ಟಾ? That means like it is not at all concentrated in any of the services, right? So definitely I can tell that it is using a minimum of overhead. Okay, say that if at all a process, okay, of a client wants to send some small message, okay, in that situation, fine, this UDP protocol, if I use it, okay, so the process should whenever it is sending a small message, no, it should be like it will be very much clear that the process is not caring about the reliability. Okay, that means some of the processes, they does not care much about this kind of reliability. Okay, so that situation the UDP can be used, right? So in order to even send a small message between the client and the server, okay, there is no connection or interaction between the sender and the receiver. That means like unlike your TCP, if you remember, okay, in TCP we used to have three-way handshaking, right, where I'll be having a server, source and a receiver or destination, right? He has to first send a request, then receiver should acknowledge, right? And after acknowledging, the sender should go for a connection, in the sense sending the data to the over the channels, right? No, so there was three-way handshaking. Means it was concept of connection establishment, okay, and even the connection termination. But in UDP, okay, no connection establishment, okay, And there is no connection establishment means there is no connection termination. Right? Okay. So there is no connection means why, where to terminate, what to terminate. Right now. So here when we talk about the user datagram, okay, the packets of use UDP, that is user datagram protocol, are called as user datagrams. Okay, the packets of UDP are called as user datagrams, and these datagrams or the packets, they have a fixed size header, okay, of 8 bytes. Okay, say that I have a user datagram, okay, and this is the header part of it, okay, and this is the packet data. Okay, let me call it as data. Okay, the header is of, what is the length of the header? It is 8 bytes. Okay, you can see very less number of bytes right now, but in case of TCP we had around 20 bytes minimum to 60 bytes of maximum header, if you remember, right? Minimum was 20 bytes. But it was doing a lot of work also. But here there is no, I mean, extra things which is UDP is doing. So definitely header will be having very less information to carry. Okay, and this header is segmented into 4 equal segments. Okay, and each is of 2 bytes. Okay, or 16 bits. Okay, so here the first two fields whatever we have, okay, let me write only the header part here. Zero, 16, 31. Okay, first is the source port number. So small header, right? But in case of TCP, you have seen the length of the header itself. So a lot of information it was carrying, right? So here UDP header is having source port number, then destination port number, okay, and we have a total length and checksum. Okay, so here when you try to see the source port number, okay, and destination port number, there are 2 bytes of 16 bit each. Okay, so total length it can be starting from 0 to 65,535 bytes. Okay, however the total length needs to be like less because user datagram will be stored in the IP datagram, right? No, so with the total length of 65,535, IP datagram length would come. That is why user datagram length has to be like quite less. Okay, and need not be that 65,535, but assume that we will consider. Okay, normally we will not be having so much of total length. Okay, especially with respect to UDP. Okay, and last it is checksum. Checksum is basically used to see if at all the packet is having any error or not. Okay, so to have that clarity, this particular checksum is added in the header. Rest no information because it is not at all bothered about any other operations related to it, right? Now consider that I told you this is 8 bytes and total length, the minimum should be now 8 bytes to 65,535 bytes. Okay, now when I just told you that minimum header length to be 8 bytes, as an example I'll give you one user datagram. Okay, now looking into the header of UDP, you just give me some information whatever I will ask now. Okay, that means let me consider that I have a user datagram protocol or a packet, right? So example I'll give it as CB840000D 1C. Okay, I'll give it as 1C. Okay, then okay, let me take 1C only. Okay, now this is the hexadecimal format of a UDP. Okay, UDP header. Fine, I'll write it as UDP header. UDP header is how many bytes? 8 bytes. Correct, no? So now you tell me, see, the header comprises of 2 bytes of source port number, destination port number, total length and checksum. Now I have given you the header here. Okay. My first question is, somebody answer, what is the source port number? What is the source port number? Anybody? Yes. You can see Aram say, see, first segment, second segment, third segment, fourth segment. So I have four fields, 4 segments here. Now the first is what? Source port number. Correct, no? So what is the first segment I have? The source port number. It is nothing but the first 4 hexadecimal digits. Right? Because I have represented in a hexadecimal format. So CB84. So this is an hexadecimal. Okay, if you want, you can write it in even decimal also. Maybe it comes around 52,100. Okay, so this is the source port number. Okay, first field. Now I have answered one question. Just let me know what is the destination port number. Anybody can answer. What is the destination port number? Yes, I'm audible, right? Hello?
Yes, ma'am.
Yes, answer me. What is the destination port number? Can you see the second segment here? See, in the second segment, we have destination port number. Just tell me the value if you are alive in the network. Now, I just gave this example to interact with you people. That's it. No other intention. Because you people were silent, so I just thought that let me get some interactive answers from you. Okay. Okay, let me finish it up. That's it. When you are not able to answer, why to scratch my head? So the destination port number here is the second part of your header. I have shown here 000D. Okay, it is a 16-bit, and probably the value of this is D is 000D 13. Next, third one, total length. Okay, so total length, what is the total length of the header? That is in the third segment, that is 001C. 1C stands for 28. Okay, next question is, okay, if total length is this, what is the length of the data? What is the length of the data bytes? I have total length is 28 minus header is 8 byte, so remaining is 20. So 20 bytes of data is attached. Okay, so like this, some of the questions will be asked. Okay, if at all they try to give the UDP header, some of the questions, if you know the header, you can definitely answer. Otherwise, you have to keep like this silent only. Next, we talk about UDP services. The only thing that UDP does is process to process communication, and I told you it will not provide any other concepts to IP, okay, any other services to IP. So one best thing that it can do is process to process communication, and that is done by using the socket address. Now tell me, what is socket address? What is socket address? I have already told you. Hello.
IP address and port number.
Yes. Who answered?
Pawan.
Yes, very good, Pawan. So the socket address is nothing but your IP address plus the port number is nothing but socket address. Now using this socket address, UDP will do the process to process communication. Okay. Next, it is one of the service it can give is connectionless service, and which is already known. Connectionless service is provided by UDP, which means that here each user datagram which is sent by the UDP, okay, it is independent. Okay, that means here we don't tell exactly as a packet. The different name we have called is user datagrams. Okay, user datagrams are independent, they are not dependent. Okay, that means there is no relationship between the user datagrams or the packets. Okay, even though they are coming from the same source and going to the same destination, there is no dependency. Okay, that is what we call it as connectionless. Okay, and also services, there is no connection establishment between the source and the destination. So when there is no connection establishment, as I told you already, definitely there is no connection termination also. Okay, and one more is like flow control. Okay, so definitely there is, UDP is a very simple protocol. Okay, it will not take risk of doing anything else. That is why there is no flow control in UDP protocol. Hence, if there is no flow control, there is no need of setting up the window here. Okay, that is no window mechanism in case of UDP protocol, because even though the receiver is overflowing, okay, sender will never even bother. Okay, that means receiver may overflow with the incoming messages, and since there is no flow control, there is a possibility that data may be lost. But only the thing is, if a sending process, okay, is sending the packets at a slower rate, or he has to take care of it, that means here UDP will not do anything. Okay, only the process which is using the UDP, that should provide this service. That means the service of flow control. I hope you are understanding. UDP will not do anything. Okay, only process should do. While sending, that only should send it in a limited way or slow rate. Okay, that means the rate of movement is like less. So those things he has to take care. UDP will never even analyze about the flow control. Because of no flow control, no window, no congestion window mechanism concepts is there in UDP. Okay. Next is no error control. Okay, UDP will not provide any error control mechanism except the checksum, right? Okay, and this means basically that sender does not know if a message has been lost or duplicated. Sender will not know. Okay, and when the receiver, he detects an error through the checksum, in case if the checksum is faulty, he will discard that packet silently. Okay, that means I can tell there is lack of error control mechanism, and again the process, that is the application layer. Okay, the process of the client or the server. Okay, so they have to take care of this error control process. That means a process should send error-free packets. Ideally, assume. Okay, it should be error-free packets sent from the processes. Okay, but UDP will not do anything related to error control mechanism. Okay, and checksum calculation is basically with respect to whether the packet which is received is error free or not. That's it. Okay, apart from that, no other error control mechanism is included here. Okay, like we have sender what you can say, error control mechanisms, whether the packets is lost, okay, or packet is dropped, or because of some problem packet is not reachable to the destination. So some of the things, okay, those mechanisms are not there in this. Only checking the checksum part. Okay, whatever is received is correct or not. Okay, that particular process is there in case of UDP. Okay, so when we talk about UDP checksum, okay, checksum calculation, basically it includes 3 sections. Okay, what are those 3 sections? One is pseudo header. Okay, second thing is UDP header. Third is data which is coming from the application layer. Okay, so the pseudo header part of the header, okay, is a pseudo header. What we are talking, it is a header which is a part of your IP. Okay, I'm telling, it is pseudo header is nothing but it is a part of the IP packet. Okay, in which the user datagram is encapsulated within some particular fields of the IP packet. Okay, so that I think you will study in case of when you study IP packets, no? So network layer, that time I think you might have studied. Fine, pseudo header will be there in the IP packet. Okay, now that will be encapsulated. Now, what if the checksum is not included with the pseudo header? Think that I don't have a pseudo header. Okay, that time a user datagram may arrive safe and sound. Okay, but if the IP header is corrupted, okay, in that situation it may deliver to the wrong host. Okay, so pseudo header need to be there such that it reach the right destination. Okay, that means think that I don't have a pseudo header, then in some case where IP header is faulty, okay, then what happens, the packet may be reached the wrong destination. Okay, so if at all a pseudo header is there, it will help. If some error happens in the IP header packet, okay, your pseudo header will help the IP packet to reach the right host. Okay, and the protocol has some field, okay, which is added in that particular packet to ensure that it belongs to the UDP and not to the TCP packet. Okay, and say for example, if the value is changed, okay, during the transmission, then that time the checksum calculation will detect, at the receiver end, he will try to see that there is an error in the checksum. Okay, that time it will drop that UDP packet. Okay, UDP packet is dropped whenever there is an error which is detected by the receiver. So on that time it is not delivered to the what you can say, wrong protocol. Okay, Next is we have optional, something called as optional inclusion of checksum. Okay, what happens is when we talk about optional inclusion, okay, so like whenever the sender of is having a UDP packet, okay, he will choose that he will not I mean that means like in the header itself, okay, checksum irutte but optional anta tick ಮಾಡ್ಬಿಟ್ಟಿರ್ತೀವಿ ಆಯ್ತಾ. ಆಪ್ಷನಲ್ ಅಂತ ಅಂದ್ರೆ ವಾಟ್ ಯು ಕ್ಯಾನ್ ಸೇ ಲೈಕ್ ನಾಟ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಚೆಕ್ಸಮ್, right? Okay, if you want, you do it, else no, not required, something like that. Okay, like you are giving an option, okay, you are giving a UDP packet that can choose not to calculate the checksum, right? So in this case what happens, the checksum field is filled with all zeros, okay, all zeros before it is sent. Okay, now this situation where the sender decides to calculate the checksum, but it happens that the results are all zeros, okay, then the checksum is changed to all ones. Okay, so before it is sending the packet, fine. So once it is changing to all ones, then the sender will send the particular packet to the receiver. So in other words, I can just tell you that sender try to complement the value, okay, or the sum two times. Okay, already once he has calculated, he has got the checksum is 0 and he will not send it to the receiver. Okay, then he will try to complement it. Okay, so yeah, it becomes like all ones, fine. So it is note that there is we are not creating any confusion here, okay, because the value of checksum is never all ones, okay, never all ones, very rare, fine. Even in a normal situation, never it will be all ones. So receiver will automatically come to know that when it is I mean when it is reverse complemented, or it will make all zeros, okay, and it will take it to the upper layer if at all checksum is matching. Okay, next is we have something called as congestion control in UDP. So since UDP is a connectionless protocol, it will not provide any congestion control. Okay, so here what does it means? UDP will assume that packets which are sent, okay, in a small or a sporadic way, okay, it cannot create any congestion in the network. Okay, so if I tell this is the source and the destination, the small packets which is sent, he will assume that there is, it cannot create a congestion, right? So this assumptions may be sometime may be true, okay, may not be true in today's case, right? So when UDP is used for interactive real-time transfer of audio or some video messages, okay, so in that situations these assumptions may or may not work, right? Next is encapsulation and decapsulation. Okay, so to send a message from one process, okay, to another process, the UDP protocol, okay, it tries to encapsulate and decapsulate the message. Okay, now when we have seen that UDP is basically into process to process communication, right? So at the client side, when a process starts, okay, it requests a port number, right? That is requested to whom? The process will request the port number to whom? He will request the port number to the operating system, right? Okay, now system will provide a unique port number to the process, right? Okay, so when the what happens, the port number is received. Okay, that particular process, the same thing happens here also. Okay, so that port number and other information like socket address it will create. Okay, so based on that it will try to, that means he'll encapsulate all that information in the packet or user datagram, and that is forwarded to the destination. Okay, so other implementations, like it can create only an incoming queue which is associated with each process. Okay, so implementation here, it can create both an incoming and an outgoing queue which is associated with the process of an application layer, right? And encapsulation is only so much with respect to UDP. No much services are encapsulated. And when I talk about the next process of service is like multiplexing and demultiplexing. Okay, so when we tell about multiplexing, if at all I'm like, definitely we use a TCP/IP protocol suite. Think that I have a host which is running with this is the host who is running TCP/IP protocol suite. Okay, there is only one UDP. Okay, but several processes which are running. Okay, that may want to use the services of UDP. See, I'm talking about, there is only one UDP, but there are several processes who wants to use that one UDP, right? So to handle this situation, the UDP uses the mux, okay, such that what happens, a priority is given for the, I mean, based on the respective select condition, only one process is multiplexed. Okay, similarly at the other end also. Okay, say that I have received, and it should be like a process to many, okay, processes. So demultiplexing also happens in the same way. Okay, whenever it is utilizing one single UDP. Okay, so what is the difference that we can see with respect to UDP and your general simple protocol or simple generic protocol? See, we can compare UDP with a connectionless simple protocol. Okay, the only difference is that UDP provides an optional checksum. Okay, to detect the corrupted packets at the receiver end, and if the checksum is added to the packet, the receiving UDP can check the packets and discard the packet if it is corrupted. Okay, and no feedback is sent. Okay, and yeah, that's it. Only the difference is optional checksum. Okay, now what are these applications of UDP protocol? When I talk about the applications, okay, although you can see that UDP is not meeting any criteria whatever we mentioned in earlier topics, right? Compared to that of your transport TCP of transport layer, UDP is not at all preferring with any of the services. So some applications, when we talk about, like UDP is preferable for only some few applications. Okay, few applications, where the reason is that some services may have some side effects, okay, that are either unacceptable or it is not preferable. Okay, so second thing is like an application designer, okay, he needs to compromise with lot of things to get the optimum. Okay, so for example, in our daily life, say that one day delivery. Okay, now there is a courier. Okay, which has to be like sent in two option. One is very next day delivery, okay, where it is more expensive. Correct, no? See, you opt for one day delivery, they will charge extra cost for it, right? But at the same time, if you go for 3 days delivery, okay, so probably the cost is less, but again time matters, or the speed of reaching the destination. Correct, no? So here also it is the same case. Though I tell that high speed and low cost, okay, so both are desirable features, right? Both are required. I should go for low cost as well as high speed, but they are contradictory here. Correct, no? That means they are in conflict with each other. We need to choose the optimum here, right? Okay, so some of the features of UDP that may need to be considered with this kind of what you can say features. Okay, the designer will go, the application program designer will choose such kind of applications where he will not concentrate about the reliability or something. He will just throw it to the respective destination. Whether it is reached or not reached, he will not even bother, but he just wants to convey certain things to some people. He will do it. So at a higher speed, he will do it. Okay, so that means the applications, some of the applications with UDP are also considered, okay, where the reliability is not more, and even the error control, all these things, flow control may not be like included, and such applications may be concentrated with UDP applications. Okay, so I think I'll stop it here. UDP features I'll talk about it in the next class along with the some more concept. Hope it is clear to you. You just write down the definition of bandwidth. Okay. We will continue seeing an assignment bandwidth, definition of phase cycle, as well as frequency.